Saxon's Calculus Lesson 69 is about the area between two curves. And they show you a couple of diagrams at the very beginning of the lesson in which you have a curve and then another curve. Oh, I didn't mean to make them identical, but whatever. And then we're talking about creating a box in between the two and finding the series of all of the boxes in between. And of course, when you add all those areas up, you know that you're getting the area between these two curves. Now, to do that, we need to figure out which one of the curves is the equation for the upper line and which one would be the equation for the lower. And then if I find the area underneath this one all the way down to the baseline, and I subtract the area of this one down to the same baseline, I will get the area in between the two. So basically, you're looking for like an f minus g and finding the integration of the subtraction of those equations, and then of course the boundary is going to be between whatever the beginning spot and the end spot is for the high and the low point there. Yeah, they give it to you in f minus g technically of x dx, and then they say it could also represent high minus low, but I've already stated that. So let's jump into example 1. Find the area of the region completely bounded by the graphs of f of x equals x squared plus 2 and g of x is negative x, and then we are using between 0 and 1. So just at first glance, I have no idea which one is graphing an upper and which one is graphing a lower. So the first job would be to graph these two and figure it out. Since x squared is a parabola of some sort, and I don't have a number here with the x, I know the vertex point is going to be 0, 2. So there's the vertex. Because it's positive, I know it's opening upward. And just because I just need it as a rough sketch to figure out who's up or who's lower, I don't need the preciseness. Now, g is negative x. So that's a straight line. I have no b number, so I'm crossing at 0, and then my slope is negative 1 over 1. So down 1, forward 1 would give me a line like so. So now I know that the upper is the parabola, so the f of x. So we're going to be integrating from 0 is the low point, 1 is the high point, and then our x squared plus 2 minusing the negative x, which is going to change that into positive x. And so no like terms in that. So when we integrate, this becomes 1/3 x cubed. And I'm going to just put them in order here. So I'm going to jump to this one. So 1/2 x squared and then plus 2x. And then we're going to plug in the 1. So that's going to be 1/3 plus 1/2 plus 2. And then we're going to subtract the lower answer from that, which is 0. But when I plug in the zeros, I lose the whole thing. So I'm just working on this part. Common denominator of 6, which would make 12, 3, 2. So 2 plus 3, 5 plus 12, 17 over 6. And again, I don't have a measurement, but it's going to be units, and because it's area, it's going to be squared. Now, let's work on example 2. Find the area of the region completely bounded by the graphs f of x equals 2 minus x squared, parabola opening down, and g of x equals x. Again, I need a rough sketch so I know who's on the top. All right, so my center point will be, now that's a negative. I want, no, I'm going to do 0 negated is still 0, but the 2 is on the outside. The negative is not affecting it. So 0, 2 is still the vertex point opening downward. So there's my rough sketch of the parabola. Then g of x is x, so that's like 0, 0, 1, 1, and so on. So I'm going to have a line going this way. So again, the parabola is above the line. So we're going to integrate from, oh, I forgot to write down what it said. Oh, it didn't say. Which means it is expecting me to find, I need to extend this. It's expecting me to find the two places in which these cross because it's naturally bounded between here and here. Okay. Come back to that in just a split second. So then I know I'm doing 2 minus x squared minusing the x to get the area in between them. Now I'm going to go back and find these points. If this were on graph paper, I feel fairly confident that I would know for sure where they are. But assuming that I'm fairly close, I think that that is 1, 1, and that one is negative. Oh, I don't trust this one as much. Negative 2, maybe. When I'm not certain because I didn't do it on graph paper, what I need to do to test that is to plug it in and actually see if that works. So, well, negative 2 is negative 2. That does, oh, and what, yes, okay. It would have to, because I don't think that's negative 3, but let me just test it up here. Negative 2 squared to 4, negative 4. 2 minus the 4 is negative 2. Yes, okay, so I feel fairly confident that that is the correct boundaries. So we are going from negative 2 to 1, negative 2 being smaller, 1 being the higher. Now we have our boundaries. Okay, so let's integrate, and that's going to give us, again, I want to put them in the right order. So negative 1/3 x cubed minus 1/2 x squared plus 2x. Oh, they didn't put them in order, but that's okay. Now let's plug our numbers in. So 1 being the higher is going to be negative 1/3 minus 1/2 plus 2, and all of that will minus the lower answer plugged in of negative 2, so that will be negative 8, so positive 8/3, negative 2, positive 4, half of 4 is 2, so negative 2, and then negative 2 times positive 2, negative 4. All right, now common denominators of 6 again. 6, 3, 6, 2. So that's negative 2 minus 3. Negative 5 plus 6 is 1/6 minus, and then common denominator, well, no, I could do them all in common denominators, but negative 2 and negative 4 is negative 6. Then if I common denominator to 3, that's negative 18, so negative 10 thirds, which is going to make that positive. So 11, I've dorked a number somewhere because they're telling me it should be 9/2. Pause while I find it. Found it. I questioned it when I wrote the 6 here, and I didn't actually write the 12 here, and I think that threw that off. So negative 2 minus 3 is negative 5, plus 12 is 7. Okay, so let's see if that fixes it. And then I went ahead and wrote down the common denominator here, made 6, which changed that to 20. So 7 plus 20 is 27/6, which will reduce down by 3 to a 2 and a 9. Yes, there's our 9/2 units squared. Yay. All right, example 3. Find the area of the region bounded by the graphs of f of x equals 2 minus x squared and g of x equals x and x equals 2. So I need a sketch to see what I'm dealing with. Parabola again, negative. Oh, it's the exact same thing. Okay, so we can go ahead and do this and bring that down. So we know that we have a spot at like 1, 1, and at, oh, I feel like I'm graphing that badly, because that should be a spot at -2, -2. Oh, I don't know whether I need to be accurate. That does not look right. But I know it is supposed to be. You know what? I'm looking at their picture. I can see that it doesn't really matter on this side. Let me go back to just kind of saying it's here and not worry about this part. If I need it, we'll fix it. Okay, then g of x equals x. That's what we had before. It's the same graph going through. That was my 1, 1, 0, 0. So it's, okay, here we go. All right, we're getting there. And then it says x equals 2. So at 2, I'm going to have 2, 2, about in there, I think. Okay, and then we're bounding here. So they're saying we want, oh, I do need to fix that side, underneath the line, stopping at this one, but outside of the parabola, which should hit here. Yeah, I just drew the parabola really badly. So it's this section in here that we're dealing with. So I only need this part to give me the boundary between 1 and 2 for when I integrate. And then the top equation is the line. So we're going to do x minus the 2 minus x squared, because the line is now above the parabola. Okay, integrate, we're going to get, I don't even care about the order because they're not caring about the order, so let's just do it. So this becomes 1/2 x squared. That's minus 2 when I distribute that, so that goes to minus 2x, and then that's a positive x squared, so that becomes 1/3 x cubed. Now let's plug in our 2. 2 squared is 4. 4 divided in half is 2. 2 times 2 is minus 4, plus 2 times 2 is 4 times 2 is 8. So that's that 8/3, and then we're minusing, plugging in the 1. So 1/2 minus 2 plus 1/3. Okay. 2 minus 4 is 2 plus 8/3, common denominator of 3. So 8, 14/3 minus, okay, then 1/2. Let's just go ahead and common denominator everything to 6. So this is 2, this is 6. Make sure I wrote my 12. 6 and 3. So 3 minus 12, -9, -7 over 6. Changing that to a positive. 21 over 6. No, wait, that's not a common denominator yet. Common denominator of 6, which makes that 28. 35 over 6. Uh-oh, they have 11/6. Oh dear, am I having trouble doing math today? Well, as soon as I started checking my numbers, I realized I failed to write a negative here because 2 minus 4 was -2. So that should be -6 plus 8. 2. If you make that a 2, and then you change the common denominator to 6, that's changing that to a 4. 11 over 6? Haha, that was the error right there. 11 over 6 units squared. Now, example 4. Find the area of the region bounded by the graphs y equals x squared and y equals 2x squared minus 4. Since it didn't give me any boundaries, I'm going to assume that the picture itself will provide the boundaries. So x squared is definitely a parabola. 0, 0 is its start. It's positive, so it's going up. But since I need it to do the boundaries, I need to be accurate. So that's going to be 1 gives 1, 2 gives 4. Then -1 gives 1, -2 gives the same 4. Here's my very accurate parabola. Now, crossing the y-axis at -4, counting a slope of up 2 over 1, up 2 over 1 is giving me, just a second. I'm graphing this as a line. That's an x squared. That's a parabola. Hang on a second. Oh boy, I am having troubles today. So there's no number with 0, -4 is an accurate vertex point. Yes, okay, so then what we need to fix maybe these. 1 plugged in gives me 1 times 2 is 2. 2 minus 4 is negative. Oh, that one's accurate. I'm gonna guess this one's not, maybe. Then mirror imaging that would make it here. Okay, do 2. 2 squared is 4 times 2 is 8. 8 minus 4 is 4. Oh, that's this dot. Okay, so yes, this was incorrect. This and this one. There's the two parabolas. Okay, so we're bounded between these two. That's our section. And that's double checking my boundaries. I feel like that is here. I feel like it's hitting in between them. On their picture, that's their -2, 4. Yes, yes, it is hitting somewhere in between them. Okay, got it. It took me a second on this one. I'm used to plugging in where I'm seeing it hit the x-axis, but in this case, it's the 2 that is where they're crossing, and so I'm going to use the 2 and the -2 as their bounding points for the x value. So even though this one, it should be over a little bit more, but I think you're getting the understanding that where they're crossing, those are the x values that I need to be using. So we're going to use the integration of -2 being the smallest, 2 being the highest. So this first one is the upper, so it will be x squared minus the other one, which is the lower one, 2x squared minus 4. And before I do that, I definitely want to put these like terms together. So x squared minus 2x squared is actually -x squared plus 4, because minus a negative is positive. So now when you integrate that, you get -1/3 x cubed plus 4. It was x to the 0, so that goes to x to the 1, and then dividing by 1 doesn't matter. So plus your 4x, yes. Oh, when I looked back, I realized that they actually set those two, rather than using the graph, they set the two equations together, and that's where they pulled their x's of matching 2 and -2. Either way, then you wish to do it works just fine. Okay, so now I was double checking my integration because I've had such trouble with math today. Now let's definitely plug these numbers in. So -2 being the highest one, so 2 cubed is 8, so that's -8/3, and 2 times 4 is 8. And minus the lower one, which is -2, so that's -8. So +8/3, and then -8. Okay, common denominator of 3. 24, 3, 24 again. So -8. So 16/3. Yes. Because I've had such trouble, I'm triple checking my numbers. And then this is 8 minus the 24. So that should be negative 16 thirds, but I'm minusing that. So that's going to change it over to positive. So then that becomes 32 thirds. Yes, units squared.